then it actually has it's now a continuous random variable. Please note that before you can tag something as a random variable, it must satisfy at least two properties, two key properties. Number one is that it must be coming from a random experiment, a random situation, and secondly, it must have a probabilistic value attached to it. I will go back to the popular superstar dataset and use that as a case scenario. Now, if you open that dataset, it has 10,000 rows, I guess, and you can see several values of profit. Now, if I'm interested in getting the chance that the company or the store itself is going to be making a profit of, let's say, $10,000 within a specific time frame. Now, 10K dollars or 10K whatever at that point in time is a it's actually a random variable, and to be specific, a continuous random variable because I've attached a probabilistic value to it rather. So please pay attention and take note of that. A random variable must come from a random experiment, and at the same time, it must have a probabilistic value attached to it. So I think I don't want to go in depth into the continuous variable and the discrete variable. I have a video on YouTube about that. I'll actually probably share that link to you guys. I don't really want to like take time on all of those stuff. So now that I've actually set the right background, so let's now move in properly. Let's move in properly into how random variables can now lead to what we call a probability distribution. Okay, so that is one of the key things that we actually have to talk about. So, how the random variable can lead to the world of probability distribution. So, we have two types of random variables, like I said. We have the discrete random variable and we have the continuous random variable. Now, that now leads us to two questions. What is a probability distribution? Okay, then after defining that, then what are the types of probability distribution? So let me start with what is a probability distribution. Now, remember that I said that as far as you have a variable and that variable actually have a probabilistic value attached to it, then that thing is a random variable. Now, a probability distribution, I repeat, a probability distribution is a mathematical function or a graph that gives you the probabilistic value attached to a random variable. I repeat, a probability distribution. A probability distribution is a mathematical function, aka or a graph, that gives you the probabilistic value attached to a random variable. Okay, so let's take for example that the number of times you eat days in this week, or you eat 3 days next week. I can say what is the chance that I'll be eating 3 days in the next 5 weeks. I'm trying to attach a probabilistic value to the number of times I'm eating in a week. Now I can use a mathematical function to get probabilistic value that I'll be eating 3 times in the next 5 weeks. Now that function that helps me to calculate probabilistic value is what is known as a probabilistic distribution. Now if you are into betting, okay, you must have asked yourself that how do sporting bets, Ninja bets, all of these guys, they know the right odds. They know the right odds to give a team. So they can give Man City 3.15 or 2 point. How do you know that that is the value to give? Now, from the lowest point or in the basic point, all about probability. So they have a model that calculates probabilistic value attached to the event of probably a team is winning or losing or scoring 2 goals or scoring 3 goals or any major. Then they convert that probabilistic value to the odds. So that model has a mathematical function that can calculate probabilistic value of an event. Now that function is a probabilistic distribution. That function is a probabilistic distribution. Then you can actually graph a probability distribution, because if something has a value on the x-axis and it has a value on the y-axis, then you can actually create a graph. I hope I've actually made some sense there. Now that now reminds me, we use the letter X. We use the letter X in lowercase, no, in uppercase rather, to represent. Is it uppercase or lowercase? And we use the letter X. Anyone you want to use, we use the letter X to represent the random variable, and we use P into bracket X. I repeat, and we use P into bracket X to represent the probabilistic value of that random variable. Okay, I hope that makes sense to everyone. So, for example, if I roll a fair die just once, okay, I have 6 outcomes. So that is 1, 2, 3, 4, 5, 6. So there's a chance that 1 is going to happen. There's a chance that 2 is going to happen. There's a chance that 3 is going to happen. There's a chance that 4 is going to happen, down to 6. So x is equals to 1. Okay, let me just try to share my screen. If I can type that, I'm actually using my phone right now, so let me see. Okay. All right. Okay. Oh, yes, that. Okay. Okay. So I have this. So x, right? I hope you guys can see my screen. So x is equals to 1. Okay. So it's a random variable. X is equals to 2. Let me just write it this way. X equals to 1 is a random variable. X is equals to 2 is also a random variable. X is equals to 3 is also a random variable. Down to x is equals to like 6. These are all random variables because these are the outcome of a fair die. Outcome of a fair die. Okay. Now the probabilistic value is written as the probability of P into bracket x equals to 1. Okay. So this probability that the 1 is going to show up. So you can get that from. Can you see my screen? Can you guys see my screen?
Yes, I can. Yes, I can see your screen.
So probability that x is equals to 2, okay, is the chance that a 2 is going to show up until you get to like 6. So x is a random variable, and P of x, you can just write it as P into bracket x. That represents the probabilistic value. So if you now want to make a graph, you can plot x on the x-axis. The 1, 2, 3, 4, 5, 6, you can plot on the x-axis, and then you can plot the probabilistic value on the y-axis. Then the graph that you have is now a probability distribution, and the mathematical function that you can extract from that graph is also a probability distribution. I don't want to go too far. I hope I've been able to make sense now. Okay, that backs the next question: the types of probability distribution. So we basically have 2 types. We have 2 types of probability. Okay, that's probability distribution. Excuse me, probability distribution. Okay, I can't these people with this. All right, so the first one is what we call the discrete probability distribution. This probability distribution, and the second one is probability distribution. I repeat, we have the discrete probability distribution and we have the continuous probability distribution. As the name implies, it's obviously straightforward. So the discrete probability distribution is made up of discrete random variables. So the discrete probability distribution is made up of discrete random variables. It's that simple. And the continuous probability distribution is made up of continuous random variables. It's actually as simple as that. I will still go back. I don't know if everyone right here have seen the Superstore data set. I'm assuming a larger chunk of us must have actually seen that it's a popular data set. But if you haven't, you can just go to like Apple and just have a look at it. It's a Superstore data set. It consists of 10,000 variables. It has like I think 20 variables. Out of those 20 variables, 4 of them are numerical variables, and that is sales, sales, quantity sold, and profit. So it has price, sales, quantity, and profit, and the other ones are categorical. We have date, we have order ID, we have uh, product category, we have product subcategory. But I'm not paying attention to the categorical side. I'm paying attention to the numerical side. Okay. Now look at that numerical variable right there. Okay, we have price. Now we have price. We have price right there. We have quantity right there. We have sales right there, and we have profit over there. 4 numerical variables. I'm focusing my attention on these 4. Now, out of these 4, okay, 3 of them are continuous. 3 of them are continuous. Only 1 of them is discrete. Quantity is discrete. Price, sales, profit, they are all continuous. Now, if we attach a probabilistic value to any of these variables, then they become a random variable. Okay, so if we take a look at our data set, so we can now say, okay, during this day 1, day 2, because it has a date, the data set has a date attached to it. So if you can like label it, so day 1, day 2, day 3, day 4, can I say, so in day 1, what is the chance? So how many items do we sell? So we now calculate the chance of selling an item in day 1. So I would have loved to. Oh my god, I'm not my system right now. Okay, this is it. If you open that data set, so you see a date. Okay, let's say 0311. But let me see if I can download the data set first. I would have loved to like use my system for this, but I'm actually out of power. It's fine. I don't know. Okay, see it here. If you open the data set, I hope you get. If you have the data set, please open it. So you can see that your first. Okay, let me ask you your first 10 variables. Your first 10 variables. So your first 10 variables is like 03/11/2013. So that's 03/11. Like that's 1 day. 04/11/2013. That's day 2. 05/2013. That's like day 3. So like it goes like that: day 4, day 5, day 6, day 7, day 8. So I can be interested in the fact, and for each of the days we have several variables that define them. We have quantity, we have day, we have order ID, we have profit. You guys know how a data set looks like on like a panel data, like a normal panel data. So if you want to perform the proper analysis and you want to know how much you are selling in a specific day, what is the chance of you selling an item on a specific day? Now you can have come like this. So what is the chance of selling in day 1? Let's say our day 1 is 03/11/2013. So that is the 3rd of November 2013. So all you have to do is to locate all the data points of the 3rd of November. Locate it, extract it out. If it is quantity you are interested in, take the quantity for each of that day. You will see 3, you will see 4, you will see 5, you will see 7, you will see 1. All the quantities that were sold in that day, sum it up, divided by the total number of quantities that have been sold all through that time frame. That is the probability of selling an item in a single day. That way, you've converted the single random variable which is quantity. You've converted the variable which is quantity into a random variable. So before you have a quantity sold for each day. So you now took just 1 day all the things you sold in that one day. You sum all the quantity up, then divided it by the total number of quantity you sold all through the data. So that is the chance of selling in day one. So you do the same thing for day 2, do for day 3, do for day 4, do for day 5. You can do by days, you can do by months, you can do by year, depending on how large the data set is. So I think the superstore data set is like a 3 years data. I don't know if it's a 3 years data or 2 years. So let's do it by month. So we have month 1, month 2, month 3. So you get the number of quantity of goods sold for a month. You sum it up, divided by the total number of quantities sold all through the month. It's an Excel function. So just use a simple formula. So you can just filter your month out, do this plus this plus this, or this down to this over the total, and you just get your number. You get your values, okay? And then you get the chance of selling a single quantity in a month. Now, at that point in time, your random variable now is a quantity because it has a probabilistic value attached to it. So you can do the same thing for month 1, month 2, month 3, month 4. So month 1, there's a chance of selling a single good in month 1. Month 2, it has its own chance. Month 3, it has its own chance. Month 4, down to the last month we want to talk about. That way, you've created a probability distribution for quantity sold. And because quantity is a discrete random variable, then you obviously have a discrete probability distribution. Now, you have your month 1, month 2, month 3, month 4, month 5. So 1, 2, 3, 4, 5 are the random variables, and each of them has a probabilistic value. If you plot it on your graph, if you plot each of those months on your graph, you will see something. You will see a shape. You will have a shape. Now that way, you see the shape that defines the distribution of quantity sold in that superstore. That way, you can now say, oh, okay, based on this distribution, we should be able to sell this number of items. Or what is the chance that we are going to be selling 10 items in month 50? So let's assume that the superstore data set gave us month 1 down to month 10. Let's assume that. So because you've created a probability distribution for the distribution of quantity between month 1 and month 10, then you can ask the question like, what is the chance that we are going to be selling 1,000 quantities in month 30? That is the beauty of having a probability distribution. Okay, so right now we have a discrete probability distribution because the variable we are using, we are converting it to a random variable, is a discrete variable, and that is quantity. If you do for sales, you do for profit, and you do for price,
You will call
sales
my name.
is a continuous
Who is
variable.
your
Yes, because sales can have
Sit
decimal.
down there.
Okay, profit is a continuous variable. Profit can have decimal. Price is a continuous variable. Price can have decimal. So if you create a probability distribution for profit, then you are going to be having, a continuous probability distribution. And that way, you can be able to calculate probabilistic value, the future probabilistic value attached to a specific price or sales or profits. I hope I've actually made. In fact, if you sell, okay, somebody says, oh my God. In fact, if you sell something, if you are someone that sells probably an item, okay, let me assume we have like someone here that sells, let's say you deliver, please, can you mute your mic? Who is that? Alright. Okay, so let's assume we have somebody that sells clothes right here. Okay, let's assume, who is that? Augusta, Augusta, please, can you tell Jimmy
Hey,
to
I'm calling you.
meet your mic?
What did you say?
Sorry, okay.
Hello?
Alright, hope you can hear me.
Yeah, I can hear you. Okay.
Alright.
Did you
I
need
was
my
telling you to
assistance?
mute some. Yes, I was telling you to mute somebody, like someone's
Okay.
mic was on.
Please give me a second.
No,
His mic is still on. You can continue. I will just.
alright, so let's assume we have, okay, Dicky is here. Dicky is my boss. He's here. Okay, let's assume Dicky sells clothes. Okay? Dicky sells clothes, okay? So, Dicky wants to create a probability distribution for the number of clothes he sells in just 1 week. So that's 1 week means 7 days. So we have day 1, we have day 2, we have day 3, day 4, down to day 7. Obviously, day 1 is Monday, day 2 is Tuesday, day 3 is Wednesday, and day 7 is Sunday. Very simple. So if Dicky wants to create a probability distribution for the number of clothes he sells for that week. So on Monday, which is day 1, how many clothes did he sell? Oh, I sold 5 clothes. You write it down, 5.
Sugar,
On Tuesday,
would
how
you
many clothes did he sell? Oh, on Tuesday, I sold
take?
10 clothes. You wrote it down, 10. On Wednesday, how many clothes did he sell? He sold 7. On Thursday, he sold this one. On Friday, he sold this. On Saturday, and on Sunday, he sold this. So by the end of Sunday, by Sunday rather, there is a total number of clothes that have been sold. Yes. Then, to now create a probability distribution for the number of clothes being sold, he needs to get probabilistic value attached to selling a cloth in each day. Okay, so let's assume the total number of clothes being sold is like 50. So day 1, he sold 5 clothes, right? So he sold 5 clothes in day 1, and the total number of clothes sold in that week is what? Is 50. So the chance of Dicky selling a cloth in day 1 is 5 over 50. You put it there. So that's 1 over 0.1. So the chance of selling a cloth in day 2 is 0. That one. Of selling a cloth in day 3, he has that one. Of selling a cloth in day 4. Now, once Dicky take the probability distribution for day 1 down to day 7, and he looks at it, he can actually use the probability distribution to predict the chance that he's going to be selling 15 clothes in day 20
15
or
clothes.
in day 50. Day 50 is like 2 months plus.
Okay.
2 months later. That's the beauty of a probability distribution. Does that make sense to you guys? Now, that way you can have say, okay, I'm expecting myself to sell this number of clothes by the end of next week. By the end of next week. But don't forget, discrete random variables, they make up discrete probability distribution. And continuous random variables, they make up continuous probability distribution. Now, whether discrete, now guys listen, whether discrete or continuous, a probability distribution actually have things that defines it. I repeat, whether discrete or continuous, a probability distribution has things that define. Number 1, it's what we call the expected value. The expected value is also known as the mean. I repeat, the expected value is also known as the mean. So your probability distribution has some things. It has the expected value, aka mean. It has the variance. It has the standard deviation. Then it has a mathematical function. Then it has a mathematical function that defines it. This is what we call the probability distribution. Okay, the mathematical function is the distribution. The graph is the distribution. So it has the expected value, aka the mean. So you can ask. So if you've done a probability distribution of goods, so they can ask you what is the expected number of clothes that you can sell in 5 months, aka what is the average number of clothes that you can sell in 5 months. You see, in business, they mostly deal with predicted value, forecasted value, expected value, average value. Okay, you've created a probability, so you are a DA, data analyst. Thank you, and you've created a distribution for price for profit. So yeah, what should we expect? What should we expect in the next 5 years? What should we expect in the next 2 months? What should we expect in the next weeks? You've done for the one down to 7. What do you expect in the next coming week? So that is the beauty of a distribution. So, like I said, whether discrete or continuous, anything that is called a probability distribution must have the expected value, aka the mean. It must have the expected value, aka the mean, the variance, the standard deviation, and a mathematical function, aka the probability distribution that defines it. Now, I know you are asking this question. So what are the types of discrete and continuous? This is where it gets interesting. This is where it gets
Yes.
interesting. This is where it gets interesting. Now, under the discrete probability distribution, we have like a lot of examples. Now, the type of distribution that you have is dependent on the property. Is dependent on the property of the distribution. In as much as I said, if you okay, you know what? Okay, I'm coming. So number one, we have the Bernoulli. We have the Bernoulli distribution. We have the binomial. We have the Poisson. We have the negative binomial. We have the hypergeometry, and so much like that.
Me.
Now,
Abife,
each of those types.
sorry, can I interrupt, please? Mamouche and MZ Kings, please can you mute your mic, or I'll have to drop you guys off. MZ King, thank you. Also, Abife, I wanted to mention that your screen is not all that clear. So while I'm recording, I can't. It's not really clear from my end.
Oh, I'm sorry. I'm using my phone.
Okay, that's fine.
I'm using my phone. Probably next time I'll use my system.
Thank you.
Hope it gets.
Thank
I'll use my
you.
system next time. It's fine. Yeah. So at least I'm actually saying the words out. So the types of discrete probability distribution, we have the Bernoulli, we have the binomial, we have the Poisson, we have the negative binomial, and we have the hypergeometric. There are more than this, but these are the most, I won't say the most popular, but the common ones. In fact, you must have heard of the binomial and the Poisson before. In fact, the Poisson distribution is very popular among this thing, like timed events that occurs at a specific rate. You understand? So I will still come back to like queue systems. Like we are using a queue system, use more of Poisson. Now, let me go back to the example I used earlier on, where I told that Dicky is keeping the number of goods or clothes he sells in a day. That is a generalized discrete probability distribution. But I did not tell you which type is it. Is it hypergeometric? Is it negative binomial? Is it Poisson? Is it Bernoulli? I don't know yet. Now, each of these guys I mentioned, right here, Bernoulli, binomial, Poisson, they have conditions that must be met before you can use them to define your data set. So, if your data set does not meet a certain condition, or it met a certain condition, use Bernoulli, don't use binomial. If it meets that one, or it has that one, use Poisson, don't use Bernoulli. So each of these distribution, each of these Bernoulli, binomial, Poisson, negative binomial, they have conditions that must be satisfied. So you might know all of them, but do you know the conditions that needs to be satisfied to be able to use any of them? Very important, very key. Aha, it's very important. Now, under the continuous, now this one is where it gets interesting. Now, to be honest with you, in real life situation, you may, don't get me wrong, you will, but you may not even come across binomial, then you may come across Poisson because Poisson is very applicable. But you may not meet binomial. But you see this continuous part, you see that under this continuous, we have one of the most popular that anywhere you go, you see it. It's very, very popular. You see it everywhere. Now, we have the continuous probability distribution. Okay. Example includes we have the exponential, distribution, we have the uniform, or we call it the square distribution, and then we have the most popular one, the normal. No matter how much you meet this guy. Now, the normal distribution is the most, I repeat, it is the most applicable distribution in statistics, in machine learning. That's because it has a bell shape, it is symmetric, it has a lot of properties that define such that real life variables are actually modeled by a normal distribution. That's why they say if you understand how a normal distribution works, and you know how to use Excel to model it, or R, or Python, or SPSS, or any of these tools. See, there's a difference between knowing it by hand. People like to know it by hand. I can use a Z table to model normal distribution for you. It's fine. It's just a plus. But now, people have moved past using Z tables, or T tables, or F tables. Me, I can read Z table. People now use Excel. So I just go to Excel, type and the function NORM in brackets, you put your blah blah blah, it gives the p value. You understand? Those are still something to come back to. But what I'm trying to say is that the normal distribution is a continuous distribution, and it is one of the most popular and the most applicable. It's something that I can't wait to actually get into. Do you understand? So we also have exponential, uniform, normal. We have the geometric. Yeah, we have the geometric. We have the geometric distribution. We have a couple of them. I can't remember some of them, but we have this. Okay. So now the thing, the honest truth is that for each of these guys here, okay, the Bernoulli, the binomial, the Poisson, the negative, the trigonometric, exponential, uniform, each of them have a formula that defines their expected value, that defines their variance, that defines their standard deviation, and that defines their mathematical equation. So Bernoulli has its own expected value formula, variance formula, standard deviation formula, and mathematical distribution. Binomial has the same, Poisson has the same, negative binomial the same, exponential the same, uniform the same, and all of those stuff. So the good thing is that you don't need to cram those formulas, because if you get to SPS, if you just click on some button, it will get out the formula for you. It will help you solve it. If you go to Excel, just type equals to, then you type NORM to bring out all the formulas, the fx, the functions that has everything you need to know. If you go to R, their coach can just like bring it out for you. So you don't need to like stress yourself. You just need to understand them, then know when to use them. Okay, and like I said, my next class, inshallah, by God's grace, I'll make it that I use my system because we're Nigeria, anything can happen. Like on they do for like 3 days. So this week I do this one class and take village people. So what I'm trying to say is that they are interested, and I'll make sure that for each of the distribution or each of these guys, I'll actually like give you practical examples, real life examples, use proper data sets, and just move on like that. So I'm gonna like stop here and pause here. And by the way, I actually have, in fact, I have a very good video on this topic on my YouTube channel. I will paste the link right now. After this class, you can actually just check it out. It's a very interesting video, and the way I actually arranged the videos, they actually followed each other, so you can actually just like just like it. And on this series, when I was using my like when I was shooting this series, I actually used Excel, I used XPS, and then I used R. 3 tools, okay? So you will really enjoy it. I'm trying to look for the okay, exactly. Here you go. Yeah. So I will send the link. You guys can go over there and tell me what you think. Exactly. This not available. It's not enough. I can send a screenshot to the notes. So I've actually sent the link to the. I've sent the link to the group. That's just. I hope and I hope I have been one way or the other been able to like explain and make you learn